Okay, in this video I'm going to show how to program a little bit in Sage, in particular programming recursively the determinant function, or the determinant of an n by n matrix rather. So here's, beginning here, the simple way to define a function that adds two numbers. So def, then the name of your function, a comma b, and then maybe what's a little more important is this colon here. Don't forget that. If you forget it, it'll lead to some errors. Anyway, then you just return, in this case, a simple function a plus b. And then you've got, let's just try it out, f of 5 and 5 adds to 10. So again, I've run all this beforehand. If you're following along, you should hit run or hit shift enter after typing all this up. Okay, now let's switch to matrices. So let's create a 5 by 5 matrix with integer entries. Here's the code for that, generating a random matrix. And one thing I want to highlight is that in Sage, the numbering for rows and columns starts from 0. That's fairly standard in computer science. So A00 is the element in what would ordinarily be called row 1, column 1. But because we start counting from 0, row 0, column 0 is the first row, first column, and so it's this one here. That's why when I run A00, it returns the entry that this is in the first row, first column, or using the Sage numbering convention, column 0, row 0. Okay, then there's a function a dot n calls that tells you the number of columns. Similarly, n dot rows tells you the number of rows, and this matrix has 5 columns, so okay, great. To get some other entries, well, here's one I made on purpose, an error I made on purpose, a 1 comma 5. That's going to give an error because, remember, this is a 5 by 5 matrix, but the rows then and n columns only go up to 4 because the numbering starts at 0. And so that's why this returned an error. And again, the key to understanding these Sage errors is to jump down to the very last line, and it says matrix index out of range. And that should tip you off that that's where the error lies. So if I type in a 1 comma 4, on the other hand, it returns a number, or it returns something at least, and it returns 9. And let's go back and see. So 1 comma 4, that's in row 2, column 5. If you start counting from 1, if you start counting from 0, so row 0, then row 1 is this row that begins with -2, and then starting from 0, it's column 0, column 1, column 2, column 3, column 4. So indeed we get 9. Okay, then some other just things from Sage. To get this command range 5 gives you the numbers starting from 0 and ending at 4. Range 3 to 5 starts at 3 but goes up to 4. And then range 2 plus range 3, you can sort of add two ranges, and that gives you, so the range 2 is 0 to 1, range 3 is 3 to 4, and so combining them you get this, it's leaving out the 2. We'll need that when we extract out the minor or submatrix of a matrix. Okay, now let's go to talking about the determinant, and our book defined it using the expansion along column or row. Okay, so here's the setup. We've got an n by n matrix, and I'm going to, so its entries are m sub I comma j, and I'm going to follow the Sage convention and the computer science and Python as well convention that indexing starts from 0. So I is going to run from 0 to n minus 1 inclusive, and then likewise for j. Okay, then the formula for the determinant, the definition our book gave, is that you do expansion by minors along any column J. And so basically it's the alternating sum. So this -1 raised to the I plus j power, that will alternate the signs as I, so I starts from 0, the first, or sorry, 0th row, and goes to n minus 1, which is the last row. And then you take the entry in row I, column J, and multiply it by the determinant of the matrix you get when you remove from M row I and column J. And so you get a smaller matrix, an n by n matrix, and then you have to take its determinant. And so this is the sense in which the definition of determinant given here is recursive. Its definition depends on the value of this function determinant at a smaller size. Okay, and then this works for any column J, so let's just choose the first column, so that's j equals 0, and then the formula becomes this thing here. The I plus j just turns into an I, and the j down there turns into 0. And so this is the formula we're going to program here. We're going to write our own determinant function, and of course Sage has its own determinant function, so the kind of the goal here is to just learn how to program in Sage or Python and give an instance of a recursive program. Okay, so let's see. So I'm going to call the function myDet for my determinant to distinguish it from Sage's determinant. Okay, and so we have this colon here, this def for defining something, a function. Okay, and then the first thing I'm going to check is that this matrix M is the matrix that is the input to our function. And I first want to check that it's a square matrix, because the determinant is only for square matrices. So if the number of columns of M is not equal to the number of rows of M, then I don't have a square matrix, and so I'm going to return an error. Okay, so that was just to make sure I have a square matrix, and then let's go on to the rest of the proof, or the rest of the program. Okay, so n is equal, let n be the number of columns. That's also going to be the number of rows now, but okay. Now, then our base case of our recursive setup is that if n is 1, so if we have a 1 by 1 matrix, then the determinant is just the number in that 1 by 1 matrix, and that's in the 0, 0 position, so I just return that number. I could have also stopped at n equals 2 as the base case, but n equals 1 is better. Okay, now let's return to the general case of n. So let's initialize a variable d that's going to eventually contain or return our determinant. So first we just set it equal to 0, and then I form this matrix n where I cut out the first column from the matrix M I was given. How to do that? Well, there's this function in Sage called matrix from columns, and so start with M and take columns in the range 1 through n. So remember, this range function is a bit funny. It starts at 1 but stops at n minus 1, and so I'm taking columns 1 through n minus 1, counting again from starting from 0. So basically n has just removed the first column. Again, I'm doing expansion by minors along the first column, so that's why I want to remove the first column. And I've got this matrix n. And then, okay, so now I'm going to go through the rows, starting from row 0. So that's what the index I is. I is in this range. N again starts at 0, ends at n minus 1. And so we're going from I equals 0 to n minus 1. And then the determinant is we've computed the determinant so far. Well, right now it's been initialized at 0 in the first step, but when I equals 0. But anyway, so then we go and use essentially this formula here. -1 to the I, mi sub 0, I comma 0, the determinant of remove row I and column 0, Okay, so here's the minus 1 to the I, the matrix, so the I comma 0 entry of matrix M, and then, so I need to remove row I in column 0. So this N is where I remove column 0. And then to remove column I, what I use is the matrix from rows function, which basically takes all the rows except for row I, which is what I want to eliminate. So range I takes the rows from 0 to I minus 1. Range I plus 1 to n takes the rows from I plus 1 to n minus 1. And so I've got all the rows except row I, and that's going to be my function, my matrix that I throw in recursively. So here's the recursive call to the my_det function. Okay, and so that will return the determinant of this n minus 1 by n minus 1 matrix, and then I go through this for loop, and then once that for loop is over, I return D. So one point I want to make is, all these if, else, fors, they have these colons, and then the indentation is very important in Python and Sage, which is based on Python. So this for loop, for example, will cover what's indented underneath it. And then once that's all done, then it will return 0 after it exits that for loop, or after that for loop is finished, because the return isn't indented. This return D isn't indented. Okay, so all right, let's check this. Well, before I check that, we'll just talk some more about taking submatrices and matrices. So here's this matrix A, random matrix from before, and then this notation here extracts starting from 1, ending at 1 less than 4. So 1 to 3, rows 1 to 3, and columns 0 to 3. So row 1 to 3 is highlighted here, and columns 0 to 3 are basically the first 4 columns. Okay, so that's just another way to get a submatrix out of a matrix. All right, here's, again, I'm going to highlight in a specific example this this thing I did here about range I plus 1 minus through n. So again, let's take I to be 2, in which case that range becomes range 2 plus range 3 to 5. And here's down here what range 2 plus range 3 to 5 is. And then if we have this matrix A and we do this matrix from columns, it's basically taking the column 0, 1, 3, 4 from the matrix A, and then comparing the matrix A to this matrix that's extracted from A by extracting columns, basically all the columns except for column 2, you see that that's exactly what's happened. This column 2, again, the counting is 0, 1, 2. This column 2 here has been eliminated, and whoops, it looks like I didn't recompile this. Yeah, I didn't recompile this thing here, so that's why it doesn't work. I mean, the answer doesn't match it. But anyway, let's check here that the key thing to check is that that the determinant my program computes is the same as the determinant Sage computes with its built-in function, and that is indeed the case here. And then let's throw in, just to check our error checking, what happens when we create a non-square matrix. So here's the command for random matrix of size 3 by 4, and here's this random matrix, and then when I throw it into the my determinant function, it says not a square matrix, so there's no determinant.